Our first speaker in this next session then is Kimberly Chapman from Morphix Technology, speaking to their wearable chemical detector badge. Kim?
Hello, good afternoon. Thank you for joining after the break. And I'm going to talk to you about the wearable chemical detector badge that we are developing under contract with the Department of Homeland Security. And as you can see from the photo, the red box there is the actual detector on that firefighter's pocket. So the situation that we're looking at is specifically for first responders, but we have further defined first responders as first on-scene responders. And those are the folks that potentially could walk into any of these situations and for the most part probably would not be wearing any type of chemical detector. So we're talking about police officers, firefighters, not hazmat, EMS, any other kind of law enforcement. And when we look at the problem, specifically talking about first on scene, first responders, and the fact that they don't have chemical detection equipment typically, when we look at that, we ask, okay, well, why is that? And one of the reasons is there's a ton of chemicals. I mean, this is just a small list put out by the National Institute of Justice that they call high, medium, and low risk toxic industrial chemical threats. But we know that there are thousands upon thousands of chemicals. And so the threat is large and very diverse. And then secondly, the problem with current chemical detection is either it's too complicated, too expensive. It only can detect a very select few number of chemical agents, or it's impractical. Maybe like the example down here that uses colorimetric chemistry, which is what we do here. This one requires you to pump this little piston pump, and so it's not hands-free. So, these are some of the reasons why chemical detection is not being worn. And then back in our phase one, we actually queried a fairly large amount of first responders, looking at 37 first responders from a broad array of organizations, the police, sheriff, EMS, fire, and as well as some of the federal law enforcement agencies. And then we were also able to sit with 12 members of the FRRG to pick their brains on what is the solution for this dilemma. And so when we talked about the concerns with existing chemical detection, a lot of what we just talked about in the last slide came up. The fact that, they're not rugged, they're not easy to use with gloves. Bottom line is for the most part, they're not available to those folks. And, of course, expense is always going to be part of that discussion, especially in this day and age. So we can't dispute that. And then sometimes it's just not recognized as a need. But then we probed a little bit closer into that. So, okay, if you were provided with a chemical detector, what does it need to do? What are some of the features that it would need to have? And small, lightweight, because we know that most first responders, regardless of what organization, is usually carrying a lot of things. They have lots of pockets with lots of stuff in them. So they're looking for something that is easy to use, easily interpreted, rugged, and requires very little training. So there's not large training budgets, nor is there a lot of time to perform training. So it has to be very, very easy to use. But maybe one of the most important things that came out of this questionnaire that we had with these folks is that they weren't all that knowledgeable about chemical detection because they left that to the hazmat guys. So the question was, well, what's the best tool for you guys? And the guys, and the question or their response back was, we don't need to know if it's chlorine or if it's phosgene. We just need to know, am I staying or am I going? Am I calling hazmat or am I okay in the situation? And so they were looking for very broad detection is really what came out of that discussion. And so then we further refine that as what is the customer requirements. And it basically boiled down to these, 8 items or so here on the bottom of the slide. Low cost, easy to use, simple, small and lightweight, wearable, ruggedized, uh, chemical class detection so they can get very broad detection. Like I said, the am I staying, am I going, yes, no. Give me a couple different alerts, audible, visual, vibratory, and just give me enough information that I know whether or not I'm safe to stay or if I need to call backup in terms of hazmat or something. So this is what we have developed as the solution. And it's a wearable chemical detection badge. And what we are doing is detecting toxic industrial chemicals in classes. And we define those classes as oxidants, reductants, pH, so acid base, and poisons. And as you could see from the photos there, it consists of 2 parts, a reusable part and a disposable part, which is the item to the left of the quarter. And that will be inserted into the reusable part. And that has 4 sensors on it that will detect the 4 classes that we talked about. So far, it is a phased approach, so we've developed 2 of the classes, which are the pH, acid base, and reductant class. And we need additional funding to do the last 2 with oxidants and poisons, and we've been working with our program manager for that. So we talked about that list at the very beginning, the National Institute of Justice. And just to give you a pictorial representation of if we make this class detection, which we're doing, what will we hit on that list? And as you can see, we're hitting 86% of the high risk, 42% of the medium, and 44% of the low risk ticks. And the good part about this technology is we can add additional things by expanding into other classes to capture some of these others and put that also onto the disposable portion. So these are the performance specifications. We are developing 4 class sensors, and we wanted to have a very fast response, less than 30 seconds at OSHA PEL, which is a concentration that you could work in for 8 hours a day, 40 hours a week. Cross sensitivity of less than 1%. We don't want it to respond if it's a smoky environment or if there's a car running and there's exhaust fumes. So we want to, minimize any field interference response. And then a broad range of temperature. We're talking about below freezing to about 120 degrees Fahrenheit. A humidity of 10 to 90%. The service life of the disposable component is going to be is 24 hours, and the shelf life in a sealed package is 1 year. And then looking at the reusable part, it is very small. It's 2 inches by 2 inches by ½ inch. It does stick out a little bit where the battery goes, and that is a AA battery. It's 1.8 ounces with the battery, so very, very lightweight. It's 11.2 hours of continuous use with that battery, and that battery can be rechargeable or a disposable. And we're shooting for a device cost of less than $50 for the reusable part and less than $5 for the consumable. So looking at the features and benefits, I think it's clear that if it's low cost, more first responders can use it. If it's easy to use, one, it's going to get used more often, and it'll, it's the training budget it won't take part of that training budget. And then the fact that it's going to be small and lightweight, it won't be cumbersome, it won't interfere with the work that's being done. And wearable is easily attaches to the uniform. That is one of our questions later is the how do we want to attach it? How would you like it to be attached? Ruggedized, we're looking for, of course, long life, and the consumable has to be easily replaced. Class detection, as we talked about, we're doing broad class detection with the 4 different sensors and fast response, less than 30 seconds. And then, of course, it's going to be provide an audible, vibratory, and visual response. So when you compare that to some other products that are out there, of course, it's hard to compare something that is in the price range that we're talking about, but with an FTIR, but it's also giving a lot of information in terms of, yes, it's safe, no, it's not. I mean, it does have it's going to ultimately have a USB that you can pull down that information, but in general, it's just a yes, no device. Is it safe or is it not? And then just looking at a scenario that we've talked about with first responders, if you look at the left, the photo on the left there, it's a stadium. And typically when you go into a stadium, there's usually a couple entrances. We're only showing one here, but you go in and there is a screening area prior to accessing the central part there. And that's where maybe if you had a portable FTIR, your pretty intensive piece of equipment, then that would be there. But what our tool would allow you to do is to put that on security or roaming police officers. And basically, each one of them is now a detector. So you have walking detectors all around you to know if the situation changes in that environment. So it's offering a lot of information at a low cost to provide a lot of protection. Same or similar situation on the right. If you had a police officer wearing, or a subway worker or anyone wearing the detector, they would be able to quickly recognize, hey, this thing is going off, and then they can alert so that you can have very quick action to some type of chemical release. So what we would like to ask of you is we'd like to understand specific scenarios where chemical detection is or has been a concern to you, because of course we want to incorporate all of that information as we develop this product or finish developing it. What classes of detection are most important to you? We've got 4 that we've talked about: the pH, the oxidants, reductants, and poisons, but are there others? And then this is a big one for us. We're, of course, a small company, SBIR. How do you purchase something like this? Would you be dependent upon a grant? Is this going to replace something else? How are you going to fund the development? And I see that question that I said was on here is not on there. We are interested in understanding the best attachment mechanism for our device to the uniform. This is a little bit about Morphix Technologies. We are located in Virginia Beach, Virginia, and I'm not going to apologize. Actually, I was, but I'm not. But we have Oceana Naval Air Station right across the street from us, and they're flying. They're flying a lot today. So if I apologize for maybe a little bit of that noise coming in and out, but very proud of where we are. We are a company. We've got about 40, 45 people here. We make chemical detection for employees and then also, of course, first responders in the military. And we are an ISO registered company. And even though we're a small company, we serve some of the largest companies in the world. This is my contact information. And absolutely, I would love the opportunity to talk to you about this project and specifically any needs that you have related to the wearable chemical detection badge.
All right, thank you
Thank
very
you very
much.
much.
Very interesting. All right, we do have a couple of comments. First one's actually a comment, and they say that FR. Sorry, I'm getting some echo. Might be off your speakers, Kim.
Oh, okay. Let's
see. Is that better? Yeah, that sounds better. All right, so the first is really a comment. Says FRRG stands for First Responder Resource Group, and it's how we pull in requirements, gaps from the first responder community. Okay, and then there's a question from Dusty. It says, do you have a current thought or plan on attachment of the device?
Right now, we actually are using Velcro.
Okay. Next question then is, could you please talk about the detection levels for the 4 classes of materials? Since different poisons will have different thresholds, how do you decide the detection level then? Thank you.
That's a great question. Actually, we are looking at the toxicity and then determining the detection based on the, so taking the most toxic and getting the lowest level of detection. So we want to be able to detect those at very low concentrations.
All right, thanks, Tim. Looks like we're out of time. I don't see any other questions. If you want to ask questions later of Kim, please follow up with the contact information you see here on the slide. And thank you, Kim. Great. Thank you again, Kim.
Thank you
Great
very much.
presentation.